Hello and welcome everyone. So let's start off with a pretty straightforward problem like this. I'd like you to take a look at this one here. So we're told that K is the midpoint of LM and we're given some information here. We want to calculate the length of LM. Alright, so as usual, it's probably a good idea to draw a picture of this here because we may not see what's going on. Alright, so here's our picture, right? So we're told you have LM here, we have K, that's a midpoint here. So as we know, midpoints, right, according to our definition, midpoints divide segments into two congruent pieces here. So LK is x minus 2, and this entire thing is 35 minus x here, right? Okay, so we should be able to figure out LM from this information here. Again, when we use the word compute means we're going to get a number at the end. All right, so considering what's going on here, well, if these are congruent, LK and KM are congruent here, that means they're the same length. So I can write KM is also x minus 2. And now we have this a small segment, this large segment here, that's the sum of these two small segments, so I can add them together. So I can write x minus 2 plus x minus 2, and this is guaranteed by our partition postulate here, is equal to 35 minus x here, right? We can set that up. So you get 2x minus 4 equals 35 minus x here. So it looks like what's going to happen here is we're going to get 3x equals 39, right? I can add x to both sides and add 4 to both sides. So now we can divide by 3 here. We get x is 13. Now, of course, we're not done yet. We had to finish the problem off. We note that in this situation, LM is just 35 minus x, which is 35 minus 13, or 22. And considering what we have here, we can actually substitute this in for the other pieces. LK, in this case, is 22. So in this case, x is 13. LK is 11. This is 11 here. And indeed, 11 plus 11, these are equal. And also, they sum to 22. Okay. So if you remembered from a couple lessons ago, we talked about this idea of what is known as the addition postulate, right? Where we can take equal things and add equal things to it. And, the previous lesson also featured the subtraction postulate as well. So one wonders, could there be others? So let's consider this here. We'll consider a situation like this. We have two people, Alice and Bob, good people here, and they happen to have the same salary. So they're both accosted by this thing we call the wealth fairy. And with a wave of its magic wand, both of their salaries instantly double. So intuitively, it makes sense that if you start off with equal things, they're being multiplied by 2, right? Being doubling means you're multiplying by 2. So we seem to have that case here. So it seems like if A equals B, then it seems like then we can have 2A should be equal to 2B here, right? It makes sense, right? You start off with equal things, we multiply by the same thing, and we get equal things at the end here. So another way to consider it here, we have A equals A here, right? Oh, sorry, A equals B here. We have A and B, again, being their salaries. And somehow we're getting to the fact that 2A equals 2B here. So we could approach it using, multiplication, right? We could know here, just like before, we're going to use we have 2 equals 2 here, right? We know we're going to multiply by the same thing on both sides. And again, this is true because of our reflexive property, and we can do that. Alternatively, some of you more clever folk may notice, wait a minute, multiplication is just repeated addition. So for instance, if I'm doubling everything, right, if I'm doubling both sides, I'm really adding another copy of this to itself. So now we're just using the addition postulate. We can actually collapse this postulate here, this thing with multiplication, into something involving addition, right? So we can kind of add that here. So we can use the addition postulate here and get 2A equals 2B. So both of these here, both of these are very intuitive ways of explaining here this idea that, wait a minute, these postulates should also apply to multiplication and division simultaneously. So what we have here, ladies and gentlemen, are what are known here. Whoops, there we go, perfect, sorry about that. What we have here is what is known as the multiplication and division postulates here. So the multiplication postulate would be if equal quantities are multiplied by equal quantities, then the products are equal, right? Makes sense here. And the division postulate, if equal quantities is divided by equal quantities, then the quotients are equal. And notice that they're going to function in very much the same way as we do with addition and subtraction postulates in proof here. We're going to function in very, very similar ways here. And we'll see how we can invoke that as we go. Okay? So this is our introduction, and we're going to be looking at how these work out in proof in a bit.